Hello, I've had a question from Unit 2, Lesson 6, number 9. I'm talking about equations of line in 3 space. So they give us, for the following pairs of equations, determine whether they represent the same line, parallel lines, or neither. So look at A. So the first thing we want to check is our direction vectors. So our first direction vector from the first equation is, and 3, 6, negative 3. What you want to do is you want to write that in lowest terms. So we're going to factor out a 3, which would leave me with 1, negative 2, and 1. Next, we'll look at the second direction vector. Looking at that one right there, which is 2, negative 4, and 2. Taking out a 2, we have 1, negative 2, and 1. So at this point in time, we know they are at least parallel. Okay, so therefore, parallel. So that's stage 1. If they're parallel, we then got to have to make the check to see if they are the same line. So moving up here, same line. So how do we do that? What we're going to do is we're going to check, is this point on this line? So we're looking at 103. Will it, or is it possible to make it equal to 2, negative 2, oops, that's not what I'm supposed to write, 2, negative 2, 5, plus t, 2, negative 4, and 2. So we want to know, is this possible? So we look at our x component first. So we know that the 1 will have to equal, so I'm just taking all the values in the x slot. 1 has to equal 2 plus 2t. Solving, negative 1 equals 2t, or t equals negative 1/2. So in order to make the x coordinate a 1, or that point a 1, t would have to be negative 1/2. So we're going to have to check that then. So if I look at the y component, does that work? So now I'm just going to take y equals, I'm just going to take the y values, so that's negative 2 minus 4t, so negative 2 minus 4, t is 1/2, negative 2 plus 2 is 0, so that works. That is definitely on the plane, or on the line. And finally, your z component, you got to check each one to make sure they all fall on the line. So we'd have z equals 5 plus 2t. So that's just taking the z values, 5 plus 2 times negative 1/2, 5 minus 1. We get a 4, and then we find out the 4, actually it had to be a 3, so this means this one actually failed. So the lines are parallel and not the same. If that value would have been a 3, so if this value, let's scroll down a bit, if that value down there would have been a 3, this one right here, then it would have been the same line. So this line shared an x and a y component, but it did not share the z, so therefore two lines are parallel, not the same. So when you do the check, you'll know at this point it says neither. So if it fails right here, obviously it can't be parallel, can't be the same line. All right, so that's your first check. Your second check, if you have parallel, then you need to do this process over here to see if they are the same line. Okay, so in this case, A is parallel lines only. So I'll leave B and C for you to try on your own with the process, and if you have any further questions, let me know, and I'll answer them as best I can.